Hello everyone, Dr. Vaughn. We're going to do a video about problem 24 from homework 4. This is one of the more challenging ones from homework 4, and this is continuing on with the other two videos I posted up about alternative bases. This time we're doing multiplication and division. So we'll start up here with part A, 32 base 5 times 2 base 5. You want to think about the standard kind of algorithm, so we'll put our 32 up at the top and then times 2. And the only thing we have to remember is that we're multiplying in base 5. So 2 times 2 is 4, which is still 4 in base 5. But when I do the 2 times 3, I get what you and I would call 6. 6 in base 5 is one grouping of 5 with 1 left over. So I get 1, 1, 4. Now for part B, we're going to do 32 base 5 divided by 2 base 5, and we want to write the answer in base 5 as well. So what I'm going to do here is think about repeated subtraction, but I'm also going to do multiples of 2. So we're going to start with 2 in base 5, and then 2 times 1 is 2. 2 times 2 is 4. 2 times 3 would be 6, is what you and I would call 6, but that's one grouping of 5 with 1 left over. You could also think about adding 2 each time in a base 5 system. So plus 2 here is going to give me 1, 3. And then I'd have 1, 5, but the 5 gets traded in, so I have 2, 0. And then I'd have 2, 2. And I want to keep going until I get up to something that's close to 3, 2. So I have 2, 4. And then I'd have 2, 6, which really the 6 now cashes in for another grouping of 5, 3, with 1 left over. And see, 31, or 3, 1, is 1 unit short of 3, 2. So I'm going to have this many multiples of 2 with 1 left over. So I already know the remainder here is going to be 1. And now I need to just count these up. 1, 2, 3, 4, 5, 6, 7, 8 multiples of 2. All right, so this 8 in base 10, so think 8 in base 10, but now I need to write that in base 5. So that's one grouping of 5 with 3 left over. So I'm going to have 1, 3 in base 5. That's 13, or 8 groupings of 5, remainder 1. All right, and all the rest of these kind of work the same way. You just need to be super careful with your kind of base system. So now we're going to do a 2-digit problem, 4, 2 times 2, 4, and we're in base 6. All right, let's try it over here. 4, 2 times 2, 4, and we're in base 6. So I'm going to start with 4 times 2, which is what you and I would call 8. In base 6, this is one grouping of 6 with 2 left over. So I'm going to put my 2 down here and carry the one grouping of 6 up to the next column. Now I have 4 times 4, which is what you and I would call 16, plus the one that I carried over, that's 17. But in base 6, that's 2 groupings of 2 with 5 left over. 12 plus 5 gets you to 17. So 17 in base 10 is 2 groupings of 6 and a 5 left over when I'm writing it in base 6. All right, now I'm going to start with my 2 times 2 and again get 4, which in base 6 is still 4. And 2 times 4 in base 6 is 8. And 8 is one grouping of 6 with 2 left over. So I'll do one grouping of 6 with 2 left over. And now I'll add 2. 5 and 4 makes 9. 9 in base 6 is one grouping of 6. So I'll carry the 1 with 3 left over. 1 and 2 makes 5, which is still 5 in base 6, and then bring down the 1. So I have 1, 5, 3, 2 in base 6. Part D, we're back to division. So 220 divided by 4. I'll start writing out the multiples of 4 and then see how big I can get, how close I can get to 220. So we'll start with 4. 4 plus 4 is 8. That's one grouping of 5 with 3 left over. Add 5 to that. Add 4 to that. That's 1, 7, which is 2. Carry the 1 from the 5. The 7 is a 1 and a 2, right? One grouping of 5 and 2 left over. So I have 2 groupings of 5 with 2 left over. I can also do 4 times 4 here, which is what you and I would call 16. And that's 3 groupings of 5 with 1 left over. 4 times 5 is what you and I would call 20, and that's 4 groupings of 5 with 0 left over. Then I think I'd be up to 4 groupings of 4 with 4 left over, adding 4 to get to the next one. 4, add another 4 after that, that's 4 and an 8. That 8 becomes 1 grouping of 5 with 3 left over. So I have a 3. Carry the 1 and the 4 makes a 5, which now becomes 1 grouping of 5 with 0 left over. I'm going to add 4 to the 3, that's going to be 107, which is 1 grouping of 5 with 2 left over for the 7. I add 4 to this, that's going to be a 6, which is going to be 1 left over, and I get 1, 2, and a 1. Then I'm going to add the 4, and I'll get up to 1, 2, 5, which is 1, 3, 0, when I carry that grouping of 5 over to the next column. See, we're still going. We're trying to get up to 2, 2, 0. So then I have a 1, 3, and 4. Then I'm going to have 1, 3, and 8, which is a 1, 4, and a 3. And let's see, add 4 to that. That's 1, 5, and 2, which is 2, 0, 2. Add 4 to that, 206, which is 2, 1, 1. Getting close now. Add 4 to that, and I have 2, 1, 5, which is 2, 2, 0. All right, that's the number we're looking for, 2, 2, 0. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 in base 5. 15 in base 5 is 3 groupings of 5 with 0 left over, and I had 0 remainder because I caught the number exactly, 220, which is what we were trying to get up here. So it should be 3 groupings of 5 with 0 left over and 0 for the remainder. For part E, we're going to do division in base 2, which is 1, 1, base 2. Now, we'll try to do this one a little bit differently. We'll write this down as our 1, 1 in base 2 goes into 1, 1, 0, 1, 1. So you can think of 11, 1 grouping of 2 with 1 left over goes in up here, 0 times, we'd put a 1 up here. You can multiply 1 times 1 grouping of 1 is 1 grouping of 1 with 1 left over, and subtract. So I have 0, 0, put a 0 as a placeholder here, bring down the 1, still don't have enough to divide in, bring down the next one, and then get 1. So I'm going to get just the standard 1, 0, 0, 1 in base 2. I didn't have to do any conversions in this one, and there wasn't any remainder at the end. 1, 0, 0, 1 with a remainder of 0. And finally, part F, we can try to do the same thing. 1, 0, 1, 0, 1 times 1, 0, 0. 1, 0, 1, 0, 1 times 1, 0, 0. So 0, 0, and then just times 1. Works pretty much like it does in base 10. No trades necessarily, nothing to add. And I'll just put that in with 0 remainder. Well, there's no box for a remainder because it's a multiplication problem. 1, 0, 1, 0, 1, 0, 0. And that's how you do question 24 on homework 4. And Dr. Vaughn, I'll talk to you next week.